Hi.
Hello.
How are you?
Pretty good.
Good.
How are you?
Kind of tired. Hello.
Whoa.
Hi, Griffin.
Hi, Bella.
How you doing?
Pretty good.
Good.
It's like the generic answer.
Mhm.
Pretty good. It's okay. It's what I said too.
I was watching. I was just randomly watching some YouTube videos where they're like, "What do Norwegians really think about Americans?" and stuff like that. And one of the things that they always said was like, she's like, "Well, at first I thought Americans were like super nice because they're always like, 'How are you doing?' And I'm just like, wow, I'm doing great." But she's like, but they're not really serious.
Yeah. They don't really mean it. They don't actually care how you're doing.
How are you guys?
Good, how are you?
Pretty good. We were talking about answering that question. You had to be there.
Well, hello.
Just a minute late.
Yeah. How's it going, Marvel?
Pretty decent, pretty decent.
Ah, a variation on the theme. So who are we missing? Will and Nate?
Mhm.
Hmm. Oh, we'll wait a couple minutes. Nate, I guess, had people at his house working, so he might be a little busy. But Will,
Where's Will?
yeah. Where is Will? Maybe I'll have to get Paula to call him. How are you guys' classes so far today?
Fine.
Eh, usual.
I think Miss Spencer wants to punch a wall. Something in her room doesn't work, like the Wi-Fi or something.
Yeah, she's in Sister Marcian's room.
We
Hi,
started
Nate.
starting rates.
Hola.
Like,
Oh,
Jay,
a fancy notebook. Where the hell is Will?
I beat Will today.
You
He's probably
did.
watching Netflix. He's addicted.
Where
yeah, there he is.
Will!
Bob?
go waiting.
Will, you watching Netflix?
Yeah.
Do it.
How are you, Will?
I'm good. How are you?
When was the last time you got out of that chair, Will?
What?
When was the last time you got out of that chair?
Never.
8 o'clock this morning.
8 o'clock from last night.
Yeah. All right. I want to just do like a quick overview of everything today, real quick, and then we can talk about your songs, I guess.
All right.
Amazing.
All right. I posted a cheat sheet for calculus from a man named Harold. You can always type Harold calculus cheat sheet
Heroin?
in Google to find it. What's that?
Hello?
Heroin.
Whoa, Will. Whoa.
Taking this.
Whoa.
We don't speak of that stuff, Will.
Will, we don't do that.
We don't speak of
Okay,
it.
we're good.
We just do it. No.
Yeah, we don't speak of that, Will. We just do it on the low.
All right. No, not heroin. Harold. He might do heroin, but
No, we
Probably.
do black tar. That's the good stuff.
all right. So I'm gonna present. So today's gonna be kind of like an overview day. All right. So I'm just going to sort of describe things. So at the start, I mean, we did kind of go over limits and the definition of a derivative and the definition of integrals. I didn't dwell on those very much. Like most Calc 1 courses, like half the course would be that kind of thing. So we did kind of just breeze over that. So anyway, I'll explain more now, but again, I'm still going to kind of breeze over this. So here's the definition of a limit. This is called the epsilon delta definition. The idea is that, when you do absolute value for the difference between x and some number, x minus a tells you basically how far x is from a. And if you take absolute value, you don't care if you're to the left of a or to the right of a. It's just telling you kind of your absolute distance from a. And so here's a, that's a point on the horizontal axis. And your difference from a, where x is allowed to be, you can't be at a. So that's one thing to note about the definition of a limit. There's no equality. So the limit says nothing about a. Like we never, in the definition, there's no evaluation of the function at a. It's around a. So the distance from a has to be more than 0, but it's less than some difference, some delta. So when you do the limits using this epsilon delta method, it's kind of a pain, but it's kind of neat to see it. I like the method. It's just not fun to do like problems in this way, but this is the official definition, I would say. So for x within some range of some value, the function itself, you subtract it from L. So like so the function's distance from the limit that you think is the limit is allowed to be less than some error, epsilon. So you have a difference and an error. And the idea is that you basically write x minus the number that you're looking to establish the limit at, and then you set it up like this. You make a little inequality, and then you write whatever your function is minus L, or if you think you know the limit, you can put in the number for L, and that has to be less than some epsilon. And basically what you try to do is you try to rearrange these things so that they're kind of in the same form. And once you do that, we could do that at some point, but I'm not going to run through that right now. But if you can get them in the correct form, what it basically means is that, so here's some delta, here's some set of points, and there's some maximum error between the function in this. So if I input any of these, the function could be anywhere around the limit, but there's always a smaller subset of points where I can have a smaller error. And if I make it even smaller, I have a smaller error. So the idea is that if you can take this delta down to like nothing, and this is of the correct form, then it basically means that as you get closer and closer to a, the function only ever gets closer and closer to the limit. And therefore, if you can go all the way, if there's no blockage, like if you can shrink that down to 0, basically, your distance from a, then you have proven a limit. So it's kind of a complicated way of doing it. It's kind of cool to see one done. So maybe we will do one at some point. But it's kind of like the proof of what a limit really is by definition, and it's not as useful as just kind of learning other ways of doing limits. But that's kind of the definition. So this is called the epsilon delta limit definition. So if you wanted to know what is the limit technically, how is it defined in math, it's inequalities, absolute value inequalities. But anyway, if you remember at the beginning of the course, I kind of told you guys that physicists invented calculus, mathematicians for hundreds of years, didn't like it for some reason. And then they came up with the definition of the limit, and then they used the limit to define the derivative, and they used the limit to define the integral. And then they said, oh, we've put calculus on a firm foundation finally. We fixed it from the physicists. And then in the 1960s, Arthur Robinson came up, he extended the real numbers to the hyperreal numbers, which included infinitesimal numbers and infinite numbers, and thereby proved that what the physicists were doing with infinitesimals was completely fine. So again, limits were kind of invented pointlessly, but I mean, they're neat. I mean, they're really good, and mathematicians love them. So they're useful. But calculus was fine without them. You can have calculus without limits, but I don't know. Mathematicians didn't like it at first. So you can always, it seems like you can always invent new number systems, and it just like always works. It's weird. Anyway, this is the definition of the limit, technically. It's kind of neat. If you remember, I gave you that packet with Karl Weierstrass, the guy who kind of looked like Lauer. Oh yeah, Will did not remember that. Well, someday I'll give that to you. But yeah, I had a little picture like this, and we talked about it a little bit.
Nice.
Anyway.
That was cool.
Yeah, that was early in the. Yeah, on the last day of school, I'll get you that. That'll be your graduation present. All the stuff you missed. Okay, when does the limit exist? Well, when it approaches from the left hand, and there's a limit, and that's the same as the way it approaches from the right hand side. If those are both the same and in agreement, then the limit exists. When is a function continuous? Well, that's when the limit exists, and when you evaluate the function at the point where you're taking the limit to, it's the same as the limit. So that's what the definition of continuity is. Very famous functions, which I believe they break continuity. I guess I'm not that familiar with it. But who don't follow this rule are fractals. Like a fractal, you can keep zooming in, and there's like more complexity, and you zoom in, there's more complexity, and it's just like endless. So, I mean, there are interesting functions that are not nice for calculus, but they're very interesting in their own right. So that's the definition of continuity. We didn't go over this, so I guess I'll show you it now. These are special limits that people are, usually there's a, like people do proofs with them. Where'd Bella go? Jeez, Bella.
She's hiding.
I guess.
It's
So
senior
these
ditch day, I guess. You know what that means?
But we wouldn't notice, but we did.
what was that? Well, I'm going on, so good luck for
Do
him.
we have to leave
Well,
now?
I guess if we're all going.
I guess. Oh, he's back.
Shoot, dang it.
Very funny.
I was kidding. But I saw the opportunity, and I took it.
Had-
Cooper, chill.
Should have taken it too.
No.
Well, you should have. Then you could have watched more Netflix.
Yeah, just keep that heroin drip going, Will.
Yes. Yes.
So these are special limits. So a lot of times they'll prove these to you in a Calc 1 course using what's called the squeeze theorem. So the idea here is, I don't know how to explain it. You take two functions, so sine goes through 0, right? And so they kind of take two functions that both go to 0. Let me look it up real quick. If you take Calc 1 in college, though, So this probably is sine of x over x. So no, it can't be. Yeah, because that goes to 1. Let's see if they have it. Anyway, the idea of the squeeze theorem is, okay, I got this function. What does it really go to? I don't know. But I do know that the function will always be less than this function, but greater than this function. So if I can prove what these functions do at a point, and I know this function is between them, then thereby I can kind of infer that, well, if they both hit 0, then this thing has to hit 0 because it's always between. So they call that the squeeze theorem. And yeah, I guess that is. Oh, that's x squared sine of 1 over x. So that's what they're doing. And so they can prove that, well, it's always less than 1. It's always greater than -1. It's then they put x squared. So it's always less than this parabola. But it's always greater than this upside down parabola. And therefore, if those go to 0 and that goes to 0, then this must also go to 0. So they call that the squeeze theorem. So that's usually commonly covered in a Calc 1 course. One thing I haven't mentioned to you guys is, we'll do it with these ones. It's L'Hopital's rule. I don't know where that is. That should be on this cheat sheet. Anyway, his name is funny looking. Everybody loves learning about his rule because all these difficult limits become much easier once they teach this to you. So the idea is, okay, I have this indeterminate limit. So what happens as x goes to 0? Well, sine of 0 is 0. That's fine. But then x goes to 0. You can't divide by 0. So 0 divided by 0, what's that? You know, like, so you can't evaluate the function at 0. So what's the limit? What does it approach? How does it behave? L'Hopital's rule makes mincemeat of these indeterminate forms of limits. So what can you do? Well, L'Hopital's rule says, well, take the derivative of the top and the bottom. Well, the top becomes cosine and the bottom becomes 1. So what happens as x approaches 0? Oh, it becomes 1 over 1, which is 1. So L'Hopital's rule is really nice. Yeah, you have a question?
No, but Bella texted me to say that her internet cut out and then she can't reconnect.
Sure.
She said if we talk about songs, don't let the guys pick a stupid song.
What? Sure, she said
Okay,
that.
sea shanty it is. Let's go.
Sure.
So L'Hopital's rule is really nice.
I'm cutting out.
Really funny.
Oh shoot, my internet disconnected.
I'm gonna kill you guys. All right. Oh, it's back, huh? Here's another special trig. Here's another special trig one. If I plug in 0, cosine becomes 1. I get 1 minus 1. That's 0. Plug in 0, you get 0 on the bottom. So that's division by 0 again. But with L'Hopital's rule, you can just take the derivative of the top and bottom. The bottom becomes 1. The top becomes sine. So then you plug in 0 in sine, and you get 0. So L'Hopital's rule is nice. So if you ever have a limit on like a placement test or something, or like if you're doing a calc test or the AP exam, and when you plug in the number, it's indeterminate. It's like 0 over 0. Just start taking the derivative of the top and bottom. See if that makes it doable. If that doesn't work, do it again. Take the derivative again. That's L'Hopital's rule, and it's pretty nice. Okay, this is technically how mathematicians define the derivative. It is the limit. So it's based on the limit. I kind of didn't define it this way. It's pretty much identical to the way I defined it, but I didn't do the limit. I kind of did the infinitesimals. But so there's two ways to do it. So as x approaches some point c, so if you want the limit at that point c, the derivative, then you basically just take the difference between the function where x is minus the function at c. That's the rise, right? That's the difference in the y coordinates divided by the difference in the x coordinates. And as the limit as x approaches c, as you get really close to that point, that slope becomes, that's the derivative. So it's based on the limit. This other one says pretty much the same thing. Instead of x approaching c, you have a difference, h, going to 0. So you have f at some point plus a little bit. So it's a little bit off of x. And so the difference between x and x plus h is h. So it's the same thing. This is the difference from where x is. And this is the function at that x, or at c. And then this is that function being a little bit off of x. And as that difference goes to 0, what's the rise over run? It's the same thing. So those are technically how the textbooks will put the definition of the derivative. They'll do it with limits, which is fine. Notations for derivatives, you can use a prime. If it's a time derivative, you can put a little dot above there for Newton's notation. If you were taking multiple derivatives, like beyond, prime, double prime, triple prime, then you just put parentheses and you put a number of how many, usually like a Roman numeral, of how many times you've taken the derivative. You can use Leibniz notation. And usually if you're using like a computer software like Mathematica, you can enter it like this. So those are different ways of writing derivatives. The chain rule, it's, the function is a function of some other function, it's a composition. Well, you take the derivative of the function times the derivative of the internal function. Here it is in Leibniz notation. If you take a derivative of a function with a constant multiplying it, just take the derivative of the function, leave the constant there, it multiplies. That's the constant rule. If you have a sum or difference, you can do it term by term. So if you're doing it on a sum, just take the derivative of the first thing plus the derivative of the second thing. Like it just goes into the separate functions. Product rule, quotient rule, derivative of a constant is 0, even pi. Here's the power rule. Here's a more general power rule. So if this is not x, if this is some function, just do the power rule, but do the chain rule. Do the derivative of the thing, the base. Anyway, hopefully that all kind of makes sense. Natural log, natural exponential, logarithm, exponential, trig functions. We didn't cover the inverse trig functions. So if you're going to do the AP exam, you probably want to either have this sheet with you or practice some of these. I mentioned hyperbolic. I mentioned some hyperbolic functions to you, but we never really did anything with them. That's really beyond calc, intro calc. And then you could do the inverse hyperbolic. So also position, derivative of position is velocity, derivative of velocity is acceleration. We've gone over that. This is just basic stuff from pre-calc, right? Except for this. So vertical asymptotes, horizontal asymptotes. Concavity, take the second derivative. If it's positive, then it's concave up. If it's negative, it's concave down. Where the second derivative is 0, that's where the concavity might change. Hopefully you guys remember that. It's also called the second derivative test.
Yeah, I kind of remember that.
Good. Was that we? All right, Nate. What are you doing? Shut it off. All right. If the first derivative is positive, then the function is increasing. If the first derivative is negative, then it's decreasing. And if it's 0, it's flat. These are the stationary turnaround points. First derivative test basically says that. Second derivative test talks about concavity. So if the second derivative is positive or negative at one of the stationary points, then those are either maxima or minima. Points of inflection or where that's 0. We've gone over all that. Here's what you guys struggle with. Function, equations of a line. So when you find the tangent line or the perpendicular line, you guys got to know the different forms of a linear equation. The slope will be the derivative at that point.
Yeah, this stuff, the algebra stuff, no bueno.
Yeah.
Yeah.
I'm sure I'll struggle with all of this, so
Really?
well,
Wait, what'd you say? Adrian?
I said I'm pretty sure I'll struggle with all of this.
Yeah, even if I have this sheet, I'll look at it and be like, huh, what does this mean?
Well, I just wanted to
It'd be
give
like,
an overview. So you do your
which
sum.
one should I use?
I do like this approach.
What's
Then
that?
I can watch this like whenever and be like, oh yeah, we did talk about it. Like a minute.
Yeah. So Rolle's theorem, we did that, right? So if the function equals the same thing, if at A it's the same as at B, and that means there's some point where the slope is flat, we did Rolle's theorem. So you found the C where the stationary point was, basically. The mean value theorem was the more general form of Rolle's theorem. His is a special case of the mean value theorem. The function does not have to return to the same value, but between A and B, there's some point where the average rate of change is equal to the derivative at some point. So that's the mean value theorem. Intermediate value theorem is super easy. If the function is at A and then later it's at B, it had to pass in between. So it had to cross through W at some point. That's pretty straightforward. Calculating differentials, blah, 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 Newton's method. Yeah, related rates. Oh, there's L'Hopital's rule. So if you have an indeterminate limit, you can just take derivatives of the top and bottom until you get something that's doable. We haven't really gone over summation notation. These are good to learn the sums just for fun. I mean, and also for math team. But you'll need them more in like a Calc 2 class. So you won't have to worry about them right away. Riemann sums or Riemann sums, I forget how to pronounce his name. You have the left-hand sum, where the function touches the left hand of each box, and that's how you approximate the function. You could do it with the right-hand sum or the middle. Here's the middle sum. Where'd Adrian go now? Adrian. What was
It was an
that?
accident.
Mm-hmm.
I promise I wouldn't just leave.
So here's the midpoint Riemann sum. Here's the trapezoidal rule. So like the left and right are both touching. Simpson's rule, we didn't go over that. Here's calculators, just in case you didn't know what they look like. And then integration rules. So if you take the integral of a function, you get the antiderivative plus a constant. The derivative undoes the integral. Integral of 0 is a constant. Integral of a constant is a linear. If you have a constant times a function, you're taking the integral. Just take the integral of the function and multiply by the constant. If you got multiple terms, you can take the integral of each separate term. Here's the inverse power rule. Hopefully you guys have that memorized. Riemann sums look like this when you write them out technically. In the limit of the Riemann sum, as you make tiny, tiny rectangles, is the integral. So that's just one definition of an integral. Fundamental theorem of calculus is that if you take the integral of a function from A to B, you will get the antiderivative evaluated at B minus the antiderivative evaluated at A. That's called the fundamental theorem. And then here's how you do the average value of a function. Just integrate the function and divide by the length of the interval. Mean value function, you just multiply by you find the average, I guess, and then multiply by the side of the interval. And then here's stuff that we've been doing, U substitution. integration by parts. I didn't know they had a D. Liated. That's kind of new to me. Your liate. Partial fractions, we haven't done that. We're not going to do that this year.
You've been liated.
Yeah, I guess so.
Something like that.
And then the trig substitution, I'm not having you guys do that. That's kind of a pain. Or at least I remember it being kind of a pain. When I was in school, here's different software that you can use. Partial fractions we're not doing. This you guys should kind of know. Like, hopefully you used it in algebra at some point. So if you have a geometric series, this is the sum of the geometric series. And if you take the infinite limit, so if you did the whole infinite many terms, you have the common ratio times the starting value. That's the sum of the whole thing. I don't know. You guys might not have used that much. This convergence test is for Calc 2. Taylor series we did do. That's how we approximate functions with polynomials. Every term adds more, makes a better approximation, gives you what they call a larger radius of a convergence where they look similar. And that's it. That's pretty much, I mean, we're also going to do volume integrals and other applications of integrals. So I guess we go a little bit beyond this, but I mean, that's pretty much an overview of everything. So I thought that'd be helpful for you guys for writing lyrics, just to have a big map of every topic for the most part.
Can you post this on the classroom?
I have already.
That's awkward. Can you repost?
Is it not?
Absorb the knowledge.
Oh, that's what it is? Oh, okay,
Yeah.
that makes sense. Oh, hey, we go back to the classroom.
Mm-hmm.
The Big Mac.
When I posted last class's video, I posted all the videos. So I did the one where I did all those integration by parts.
Uh-huh.
And then I screwed up on those questions. And then I posted the blooper where I tried to do it real quick before the meeting. And then I posted last class where I corrected it. So that's up. But last class, because you showed that whole music video, I was blocked from, like, no one could watch that video until I removed the song. There's still a
Copyright claimed.
Yes. Look, like if I go to YouTube.
You've been copyrighted claimed.
Oh, I watched that. That's kind of
Oh
funny.
my god.
Donald Trump fighting news reporters with a baby.
I'm gonna ask one of the other folks that sit down. Pardon me, ma'am. There's something that's
Oh my god.
on the Russia investigation. Are you concerned that you may have? I'm not concerned about anything with the Russia investigation because it's
That's too good. Sorry. How do I get to my YouTube studio?
You getting any money from that?
No.
Watch your profanity.
Oh, they went to public.
Oh, look, it's Nate. Oh, look, is it Bella?
Oh, yeah, that's me.
There's one with you, Adrian.
Oh, it's not.
I look stupid in most of these.
Will's in that one too.
This is good.
Baby's 10. Will, you're
That's
so
me in Florida.
Was that
That's
Florida?
amazing. Yeah, that one.
And then
That was
here's
that's
back.
Florida. Yeah. Mhm. Was
So-
that yesterday?
Oh yeah, see, copyright claim.
Oh my god. That's so funny.
This one was blocked until I no, this one was until I had to chop out the
Music.
song, yeah. But I left the part with the Big Mac, so that has been immortalized. All right. Well, I wanted to do that overview for you guys. What do you guys want to work on your song?
Well,
I feel bad if Bella's not here because
Oh, Bella.
she'll decide something bad and she'll get sad.
True.
okay, I'll call Bella. Where's Bella?
Okay, go for it.
Yeah, I can get her on speaker or something.
Yeah.
I mean, she should be able to answer the Google Meet with her phone.
Oh, that's true. That's true. She
Oh,
just
so-
really didn't want to be here.
Hey, Bella. You're here to help us pick out a song.
Wait, I have to leave and come back again.
Okay. Okay, so I got my song. It's way too long, and I was trying to think of lyrics, and I couldn't.
What was it?
For American Boy.
That one. It's too long.
Yeah,
Yeah.
see that I already knew that.
Are there
Mr.
enough
Dustin, where'd you go?
right now?
Above the TV.
Do you guys have any ideas?
For songs?
Yeah.
I have your meme above the TV.
Is it up there?
Yeah,
Wait, you have to write that down. Write that down.
yeah,
Nice.
it's to the right of the Salt the Hay one.
Let me think. I feel like it's weird because it's hard to like pick a song if you don't know if you can write lyrics for it, you know?
Oh, you'll get the lyrics. Don't worry.
Well, Bella just said she tried to write for American Boy and she couldn't write.
I'd have to hear the song and know the.
I'm telling you, the Fray.
What
only
about
how to derive?
what about arguably the best song in the world, Girlfriend by Avril Lavigne?
Maybe.
Do you want to play the video, Mr.
Piano
Simon?
Man.
So that they're refreshed? Please?
I don't want more copyright claims.
No, it's fine. Don't worry about it.
Oh, okay.
Avril Lavigne would never copyright claim you.
Wait, it was 9 o'clock in the library. The
Wait, you
couch
should play it.
shuffled in.
Wait, Mr. Sotelo, play it. Don't worry about the copyright. It doesn't matter.
All right, I'll stop presenting so we don't do the video. Maybe that'll help. What is this, Girlfriend?
Yeah.
I think Piano
Wait,
Man.
I wanted you to see the video. It's iconic. She
I'll
plays both
see
characters.
it. I'll see.
Okay,
it.
okay. She plays the girl and then she plays the other girl, like Taylor Swift did. It's iconic.
Oh, that's funny.
Good grammar and spelling are important, but if you want to write essays that inspire,
I do.
Okay, I just remembered it's not entirely clean, but it's not bad.
When was this made?
11 years ago, 2009. Dude, she's going
We're
off.
not doing that, by the way.
Wait, she's going off though. Look at her. Oh my god. Actually iconic.
Well, can you hear them at all or no?
Yeah, I'm hearing that. We're not doing that song.
Yeah, we're not doing that song, Adrian.
Please.
It wouldn't be hard.
That's
Wait, what was the
three
song?
no's.
What was the song?
That song?
Yeah.
It's Girlfriend by Avril Lavigne.
Did you hear that, Bella, or no?
No, I didn't.
What? Girlfriend by Adam?
Girlfriend-
You guys could do like a meeting in a
Avril
wig.
Lavigne.
You should have the wigs.
Yes.
Yeah, it'd be iconic. Bella,
What?
hear me out.
Oh, I'm listening.
Are you listening to this song?
No,
Go
I
watch, go watch the music video. We can't play it because Mr. Sotelo is afraid of copyright, but go watch it.
Wait, he's afraid of copyright? Wouldn't any song be?
Yeah, we already got copyrighted on the video with me playing the Fray for so long.
The last two videos we recorded.
The last two
No,
videos.
it's absolutely iconic.
We can't do that?
Well, not posted on YouTube, the one, but if we make a parody, we're fine. It's just that because I was presenting it to the screen.
Oh, I gotcha.
It'll make it so that I have to edit the video before you guys can see it.
Like, if I really tried, I could write lyrics to that.
To what?
Right.
Avril Lavigne's girlfriend.
It would work.
To what?
Oh,
The
guys.
Fray. Bella's
Yeah,
on the,
I mean, it
Bella's
would,
on the
but
Fray train.
it would, and it'd be fine. But Avril Lavigne would
You
be
guys
better.
could totally dress up like Isaac Newton.
Dude, those wigs go hard.
Or
I've
Leibniz.
got one of those before.
Not powdered. Huge
Pidge.
hair wig. I don't know.
Look up Newton hair. Oh, see, that's not gonna get you what you want.
No, this.
Just look up Isaac Newton costume, and I'm sure they. Okay,
Just-
take out hair. Take out hair. Oh wait, how about that gray one? God, please.
Something like that.
I know that's not coming up.
Oh, look at that. Look at that.
Picture. Yeah,
That's so
would
rich.
look good.
We might have to make our own. I mean, look at that.
Okay, imagine Nate wearing one of those wigs and singing the high notes.
That'd be amazing, Adrian.
Imagine Nate wearing one of those
That
wigs
is
and singing
amazing.
Girlfriend by Avril Lavigne.
That's Newton's best portrait.
Yeah,
We're
he
talking
looks good
about
there.
wigs now, Bella.
I don't
if we
even
do
like
like
it.
that,
but he's
what's
popping up.
Look at Gauss.
Oh, he
Wait,
was a.
what color do you wear the powdered wigs.
Look at those chops.
He looks familiar.
Yeah, that's Frederick Gauss.
No, not like that. He looks like an actor.
Yeah, no, but we're talking about like powdered wigs for some reason.
Don't
For the
act like
music video.
Yeah, but I don't know why.
Euler.
Euler.
Bueller?
Why
No,
did they?
Euler.
None of these people are Euler.
Guess he wasn't important enough.
What? I guess his hair. That's probably ruining it. There he is. Euler's like the smartest.
What was he?
The smartest.
No way.
Okay,
Well-
I'm gonna go.
That
I'm
loser?
working on the frame one. Okay.
Okay, perfect.
No, no. Well, stop.
Okay, she's gone.
What did she say?
What's that? So we can do. Well, you can use Harold's notes to kind of go over to kind of remember all the topics, and then you have to come up with lyrics.
What about?
It's literally
You could throw in some inside jokes like the Carl Weezer stuff in your Yoda.
Oh my gosh.
figure.
Wait, weren't we gonna do the Carl Weezer song? Let's just do that.
No, too
Why?
much work. Bella's working on lyrics for the fray right now.
I'm telling her not to.
Oh, well, she is. Or she was.
She just left.
Yeah. If not that, though, I think piano may be pretty cool.
Yeah.
Yeah.
It's wait, what time does class start? It's 12:05 on a B day.
Yeah.
The calc class shuffles in.
Why did you say
There's our
12:05?
teacher
It's supposed to be 12.
standing next to. Wait,
You're right.
time to play piano, man.
Yeah,
But I'll
play it.
keep the mic.
There goes my copyright.
Oh my gosh, what about Uptown Girl?
They've already done one, but yeah, you could.
The absolute disrespect.
They did Uptown Function, I think.
Oh, that's not. Oh. Yeah, that's.
You just have to make sure you did a better one.
That's true. We would. Uptown Function. Is.
Why is Piano Man blocked on YouTube through the YouTube? That's dumb.
It's blocked on YouTube?
Yeah, with Newman. Newman's.
Just Piano Man?
Yes. Why would Piano Man be?
It's 9 o'clock on a Saturday.
Yeah, there it is.
Let me read through it. Is there anything that Newman specifically would? Maybe you were playing it too often, and they were like, "This kid's not doing any work. We gotta take that down."
Take it down. Take it down. Newman next year.
Did you do American Pie?
Oh, I'm playing it right now. I don't know if you guys can hear it though.
That's not bad.
Like,
It's long, isn't it?
Yeah, it's 5 minutes. We don't have to do all 5 minutes. There's like a lot of musical, like when it comes to sound, it's like all the instruments.
American Pie's 8 minutes. Maybe we shouldn't try for that.
Marvel can play the piano.
Marvel is the piano man.
Yes.
Exciting.
You're gonna have to learn a song, Marvel.
If we do this song, we gotta have like really dramatic and long like poses.
I don't think we're gonna do this song.
In the dark too.
In the dark.
You can storyboard. You know what that is?
Mm-hmm. Yep.
So you can come up with what scenes you want and kind of just do like little sketches of like, oh, we need this shot, we need this shot. And then you can edit them later. I can show you how to edit videos if you don't know how.
Please, Mr. Sotelo, I have iMovie. I know how to edit videos.
Okay. Can you add CGI?
I can add anything I want. Okay.
Okay.
iMovie is a sandbox game.
I can show you how to do Emperor Palpatine hands.
That's what our video needs.
Exactly.
Okay, we do the iCarly theme song. Everyone cool?
iCarly.
Nice. Play that one.
I don't remember
I'm
that.
texting the iCarly theme.
Are you guys all iCarly fans?
Absolutely. No one here is not an iCarly fan.
Now that it's back on Netflix, heck yeah. iCarly goes hard.
iCarly does go hard. It never stopped.
What
Too short. The whole theme. How long is
it? You guys
Wait,
watch
look up the iCarly theme and tell me how long it is.
It's so good. I know you see somehow the world
We know.
and be so wonderful. Do live life, breathe in. I know how we're gonna get there. Be so wonderful.
Mr. Sotelo, how long is the iCarly theme?
So wake up the memory.
I'll do it myself. I can't hear you over me
Get no chance and rise, you take one. Every time every situation.
How long is it be?
Guys, I haven't seen iCarly in like 10 years, and I still remember the intro.
Of course. Does the video need to be like 2 or 3 minutes?
No,
What shows did you guys watch as kids?
All of them.
Like Dora the Explorer.
Josh theme?
Drake and Josh, yes.
Let me see how long it is. Oh, the Drake and Josh theme is 3 minutes. Drake and Josh. Wait, Iconic. I don't know what you're playing. But if it's not I Found a Way, then I don't want
Just like Nate. That sounds nothing like what Nate was singing.
No, I said, what was he singing?
I don't know.
Doing.
I think earlier he was singing the iCarly theme song, but this is Drake and Josh, baby. Wait, ready?
You see the comments, Griffin?
Sorry, are you talking?
No, not really.
Okay.
It's not a difficult one.
Sorry.
I said that won't be a difficult song to
It doesn't need to be hard.
reproduce. No, I'm not saying
Oh
that.
yeah. I thought you were like, we can't do it. It's too easy. And I was like,
Like the vocals are pretty basic, like.
yeah. Nate could take it out.
Easily.
Nate, you're muted if you were trying to talk to us.
Bella said it might be cool. Bella said it might be cool. Confirmed.
Are we figuring out songs, or are we still undecided?
I think I'm decided. I know what we're doing, guys. Don't worry about it anymore.
Are they in agreement?
No one's argued, so I'm guessing.
I guess you won.
I didn't even hear what you said.
We're doing I Found a Way.
No.
Yes, we absolutely are. Why would you not want to?
Can we listen to it?
Are you not paying attention at all, mate? I played
I'm listening to my own music.
Okay, well stop and listen.
No.
Nate, literally shut up. You're being so dumb right now.
No.
Stop it. Stop the Jake and Josh slander, okay? I won't tolerate it. We're doing it.
You guys will be the first calculus class to complete a song if you actually do get it done.
Wait, really?
Yeah, they never pulled it off.
Okay, I told Bella that there was no argument over here, and she said she's cool with it. So, guess we're...
The first year, when they talked about the song, I mentioned that they should plan it earlier in the year, and they're like, we have plenty of time. And then they didn't. And then the next year, they were quite adamant, but COVID. So.
Right. But we're 100% going to do it.
All right. You'll be the first ones at Newman.
I feel bad about saying 100% now, because if we don't, it's going to be really embarrassing.
Yes.
We're going to make it happen.
I guess I take that back.
99%.
Yeah. Pretty solidly confident that we can do it, but...
It could be 99.9.
Okay. Or should we take the limit?
We're getting risky.
As we approach 100 from the left.
Mm-hmm. Yep.
Okay. So I guess we're decided then.
Maybe.
Well, like on a real note, if you have qualms about the decision, you should probably say something, because Bella and I've told Bella that we've decided. So
Well, do whatever you want. I'm just saying the phrase a good backup plan, and then a backup plan of that backup plan is called Piano Man.
Okay, what if we all write a song?
You could do more than one.
What if we all
we could do more than one.
Work that I don't want to put in.
hang on. What if we all write a song and then we see which one turns out the best? Like what goes better?
No.
Never mind. We have to. Guys, she said we have to, so I guess we have to do. She was just talking about the video, I guess, but
You are going to want to try to make a decision soon, though, so that way you guys can start working.
okay. We
It
got
doesn't have to be today, but
All right.
anyway. Yeah, are you guys good then?
Yeah. Yeah.
Okay, well, have a good weekend. Yep. Bye, guys.
Bye, Mr. Self.
See ya.
And everyone else.